Alright, good day and welcome to section 10.7 where we're talking about complex numbers. Our work with radical expressions has excluded expressions such as the square root of negative 16. Negative 16, remember this. Because the square root of negative 16 is not a real number. There is no real number whose square is negative 16. Remember, for a negative number, one number has to be positive and the other negative for it to equal a negative number, so it can't be the same number. In this section, we discuss a number system that includes roots of negative numbers. This number system is the complex number system. It includes the set of real numbers as a subset. The complex number system allows us to solve equations such as x squared plus 1 equals 0 that have no real number solutions. The set of complex numbers includes the imaginary numbers. Alright, so this is where we're headed with imaginary numbers, and the key component of this is I squared equal negative 1 and I equals the square root of negative 1. So for an example, I'll use this square root of negative 16 as it's given to us here, and so I can split this up to read it as negative 1 times 16. And then as I evaluate it, this square root of negative 1 equals I, as depicted here. Square root of negative 1 equals I, so that means I'm going to bring the I out front in this case, and then I have a square root of 16, which is a square number, so that means it's 4, so I'll put the 4 out in front, and the 4 is the coefficient of I, and I'll write my answers accordingly that way. Okay, nothing left under the radical, so I'm okay. I just leave it as 4i. Alright, couple of easier looking things now is the square root of 36. Now we'll be able to answer this. It's not a real number. It's still not a real number but we can answer it with imaginary number. Okay, so the same concept is true. I could rewrite it to be negative 1 times 36, and then it's going to end up being 6i. Square root of 36 is 6. The square root of negative 1 is I. And that's that. I've got one more that's I've got to do some factoring with it, and this would be if I had it negative. This is the third example of the first set. So here I've got the square root of negative 20. Okay, so this negative on the outside makes this negative, and however the negative on the inside, which means the square root of negative 1, that's my I, so that I is going to come out front, and then I'm left with what on the inside? Let me factor this 20 to be 5 times 4. Okay, and now I can continue. I'll go this way with it. I'm going to end up with negative I, and then with the square root of 4 is 2. I'll just throw it out here right now, and what's left over is the square root of 5. And then I could rewrite this in a nicer form, saying that it's negative 2i and then square root of 5. And there we have that one. Alright, good enough. Let's go on to something a little more challenging perhaps. Okay, here's some examples of multiplying and dividing as indicated. I'll get one more in here for division. I'll jot it down here about the square root of negative 8 divided by the square root of 2. Let's write that down. Okay? So remember, when we're multiplying these, it's not straight out the square root of 3 times the square root of negative 7, or the square root of negative 3 times the negative square root of, God, I can't talk, the square root of negative 7. So I can't do negative 3 times negative 7 to give me the square root of 21. I have to evaluate these first because of our new learning with imaginary numbers. So this in essence becomes 3 square root of 3, and then the negative 1, square root of negative 1 is the I, so that would just come out front. Okay, and then I'll multiply that to the square root of negative 7, which will be the negative under the root sign indicates an I, and then I'll leave the negative 7 because it's not a perfect square number and there's nothing I can do with that to simplify. Once I get to this point, now I can multiply these together, and I've got I times I is I squared, and the square root of 3 times the square root of 7 is the square root of 21. However, I can evaluate further the I squared because we now know that it equals negative 1. So I can write my answer as that it equals negative square root of 21. The second one here, this is going to evaluate to be 5I times the square root of negative 1 is just I. So 5I times I equals 5I squared. I squared we know is negative 1, so 5 times negative 1 is negative 5. Lovely. And finally, the square root of 27. Well, let's see, 27, that's 3 times 3 times 3. And I want the square root of that. For every 2, take out 1. So I got 3 root 3 for the first part. No I is involved, notice. And then it's going to be multiplied times 2 this square root of negative 3. So that means I'm going to have this as the I comes out times the square root of 3. Okay, so this ends up being, let's see, 3 times I is 3I, and the square root of 3 times the square root of 3 is 3, that'll be times 3, and 3I times 3 equals 9I. Aye, aye, Captain. Alright, so there's my answer for that one. And the last one here, quite nice. The index numbers are the same, so I can divide this. Negative 8 divided by 2 equals the square root of negative 4. And so the square root of negative 4 is going to be 2I. Square root of 4 is 2, and then the square root of negative 1 is the I. And you got it here. Okay. Alright, in this next area of the section, we've got complex numbers. Complex numbers are written in the form a plus bi, and the I is the imaginary part, a and b are real numbers. We can add or subtract these complex numbers, and it's very similar to adding polynomials. It's kind of like the same as what we call combining like terms. So to review that, when I have an addition sign in between, make sure you are adding, and all we're doing is combining our like terms. So in this case here, I've got 5 plus 4 is 9, and then I've got 2i minus 3i is negative 1i, or negative I, as I like to write it. So that's in the form a plus bi. Okay, next one, this is an indication of subtraction, so just like in polynomials, we are careful that we distribute the negative over the binomial in this case. I want to do that first. So this will be 6i, that's this 6i just being brought down. Negative 1 times 2 is negative 2, and negative 1 times negative I is positive I. And I'll combine my like terms of 6i plus I is 7i minus 2. However, this is not in the right form, so I want to flip this around and write it as a is negative 2, and that'll be plus 7i. And there you have it as a plus bi. And one more subtraction problem. I'm just nothing going on in the front here, and I'm just going to rewrite that, negative 2 minus 4i, and then I have negative 1 times negative 3, which is positive 3. And now I'm okay to combine my like terms, so I end up with 1 minus 4i. And I hope you find that to be nice and easy. Alright, next we're going to be multiplying complex numbers. And I have some examples here, so let's go through these. So the first one here is going to be negative 5 times 3 is negative 15. I times I is I squared. And then we remember that I squared equals negative 1. So it'd be negative 1 times negative 15 is positive 15. The one down at the bottom here is distributive property, so I've got negative 2i times 6, which is negative 12i. Then I have negative 2 times negative 2, which is positive 4. And I times I is I squared. I squared is negative 1. Negative 1 times 4 is negative 4. So this is negative 12i, and this will become minus 4. And of course, written properly, it's going to be, let's see, what have we got? Negative 4 minus 12i. Alright, so that's the answer for that guy. How about we come over here and we'll do this, looks like it's a FOIL job here, right? So I got 3 times 6 is 18. Outside is 3 times I, which is plus 3i. What's inside? Negative 24i. And last looks like it's negative 4 times negative 4i times I, which is going to be negative 4i squared, which makes this positive 4. Alright, positive 4. Negative 1, I squared is negative 1, times negative 4 is positive 4. Add the 4 to the 18, they're like terms, so I get 22. And then 3i minus 24i is minus 21i. Okay, while we're here at the bottom one, let's do that. And that is this binomial squared, so it's 2 of those, so I could take them apart. I could take them apart and FOIL them. Alright, so let's see, where can I do that at? I'll do it here. I minus 2i. And this is gone now. I'll just use these two. And I'm just going to FOIL them. So I times I is I squared. I'll evaluate later with that negative 1. I know it's negative 1. I outside is I times negative 2i, which is negative 2i squared. Okay, and what's next? Oh, you know what? That's not I in the front. Doggone it. This is 1. This is not an I, it's 1. So give me a second. Let me retract this. Okay, let me start over on that one. It is 1. Just the number 1 here. Man, I'm having a bad day here. Let's go. 1. Now let's try that. And now we'll multiply this by 1 minus 2i. Let's try that. Alright, so this 2 is gone now since I wrote 2 of them out here, and I'm going to FOIL that. So now, 1 times 1 is 1. 1 times negative 2i is negative 2i. That's outside. Inside is negative 2i times 1, which is negative 2i. And negative 2i times negative 2i. So here I've got negative 2 times negative 2 is 4. Let's see, is that plus 4? And then I times I is I squared. And I'll write up right now as I squared. Then I'll evaluate it. Alright, so here I've got 1. And, well, let's do this. 4 times I to the second power. I to the second is negative 1 times 4 is negative 4. So then I have 1 minus 4 is negative 3. Then I got minus 2i minus 2i. Let's see, outside is negative 2i. Inside is negative 2i. So that's going to be minus 4i. And that's what my answer will be. Done with that. Alright, and lastly is this FOIL, multiplication of the sum and the difference of the same two terms. Here's the sum, here's the difference of the same two terms, meaning a 6 and a 5i. Alright, so that means I'm going to FOIL it. I'm just going to FOIL it anyway, and you determine what the answer is and why it turned out to be that way. So here I got 6 times 6 is 36. Outside is negative 30i. That's the 6 times the negative 5i. Inside is 5i times 6, which is positive 30i. And last is 5 times negative 5i times negative 5i. And that's going to give me negative 25i squared. Okay, negative 25 times negative 1 is positive 25. I'm going to add it on to the 36 here. And that's going to give me 61 minus 30i plus 30i is 0. They just cancel each other out. So this is my answer. 61 is my solution. That's all there is to it. And that part of multiplying is done. Alright, our next topic here is dividing complex numbers, and as a reminder, we multiply the denominator by the conjugate of the binomial, whatever is there in the denominator. So as a reminder, the conjugate of a plus b is a minus b. And we do that for a reason of being able to multiply the sum and the difference of the same two terms, which leads us to a faster way of solving, doing the multiplication actually, but as well as that is to eliminate the radical when we were doing radicals in the denominator. And now we're advancing that to the complex numbers of dealing with the imaginary number in the denominator. Okay, so let's see, this it's kind of like removing it from the denominator is what we have a tendency of wanting to do. All right, so let's see. So if I multiply this, I'm gonna advance the shortcut way of doing that, because when we do have this, it was remember we did this in class and I ended up with the answer being a squared minus b squared. Okay, and the rapid way of multiplying this is to take the first term and square it, that's the a squared. Take the second term and square it, that's the b squared, and the sign is always minus, because you have a positive times a negative, and you're always going to have a negative for the last term when you're FOIL. Alright, so for this first example here, I'm going to multiply top and bottom by the conjugate of 2 minus 3i, which is 2 plus 3i. Okay, what I do to the bottom, I have to do to the top. Alright, so let's take care of the denominator, since that's so much fun, by squaring the first term. I'll just square it here. Squaring the second term, that happens to be a 3i, and I'm going to square that. And it's always minus in between. So 2 squared is 4, and then I've got 3i squared. 3i squared is going to be, let's see, what can I say? It's going to be minus for now, and then 3i squared is going to be 9i squared. I squared is negative 1, and negative 1 times negative 9 is positive 9. So this becomes positive 9. So I'm going to keep going this way. So this becomes positive, what did I say was? Positive 9. And that means it's going to be 4 plus 9, which is 13. 4 plus 9. Remember, I squared is gone now. That was negative 1. Okay, and then we can continue to say that 9 plus 4 is 13. Then I'm going to FOIL this guy here. So let's see, I'll put it in parentheses, and I've got what? 3 times 2 is 6. Outside is plus 9i. Whoop. Inside is 2 times I, which is plus 2i. And last is going to be I times 3i. What the? I times 3i, which is going to be positive 3i squared. And now I know that 3i squared is negative 3, because I squared is negative 1 times 3 is negative 3. Alright, so I'll just put this as negative 3, and then I'll combine all my like terms. So here I've got 6 minus 3 is 3. 9i plus 2i is positive 11i. And that I'll write over here as 3 plus 11i over 13. Okay, and I can write this in the a plus bi form by putting the denominator underneath the 3 and the 11i. So it would be 3 over 13 plus 11i divided by 13. And this is a plus bi. Alright. Here's our another example. This is a binomial with an I in the denominator. So we talked about this in class. If I do the denominator, if I multiply by the conjugate of 5i, the conjugate of 5i is negative 5i. So this would be negative 5i. Top and bottom, same number, so it's really 1 we're multiplying by. So this ends up being, what does this end up being? 5 times negative 5 is negative 25, and I times I is I squared. But what's my denominator? I squared is negative 1 times negative 25 is positive 25. And then my top here is going to be negative 30i. 6 times negative 5 is negative 30 times I is negative 30i. And then we can simplify that, right? I say 5 goes into both of these. So I'm going to have negative 6 over 5i. And the i's in between them. And the I is really the numerator. Okay. The last part is the idea of finding powers of I. And what we talked about was writing this up as I to the 0 power equals 1. I to the first power equals I to the second power equals negative 1, and I to the third power equals, what do you think? Well, I squared is negative 1, I squared equals negative 1, and I equals I. Okay, so that means I squared times I, which is I to the third, that's going to be negative 1 times I, which is negative I. Negative I. So let me just jot that down here. And simply note that I cubed equals negative I. And we have 4 terms here, so if I divide any of these exponents by 4, I'm going to think I have the remainder in my mind, which will mirror 0, 1, 2, 3. I'll match my remainders up to these exponents, and that will let me arrive at my correct answer. So let's see, I've got, let me see, I've got something like, what is I to the 11th power? I to the 11th power, or if I divide the 11 by 4, we'll do it the old-fashioned way. Divide 11 by 4. 4 goes into 11, 2 times 4 is 8. Subtract, I get 3 remainder. So the 3 remainder applies to the exponents here. So I to the 11th will equal negative I. Okay. What else have I got? Are these, no. I thought they were negatives. It's just, the next one is I to the 40. I to the 40. I'm going to divide 40 by 4. 4 goes into 40 10 times, so I know it goes in evenly, and I'm going to have 0 remainder. Right? 0 remainder. So I to the 40 equals 1. Because I have a 0 remainder. Okay, how about one or two more? How about I-50 will equal 50 divided by 4 is 12. 12 times 4 is 48. I have a 2 remainder, so I to the 50 is going to give me negative 1. And finally, the last one will be is I to the 10th. 4 into 10 goes twice. 2 times 4 is 8. And my remainder is 2. And that's referring to I squared, I to the second power, which equals -1 as well. Just like I to the 50 was the same answer. Okay, and that's how you do the powers, finding each power of I. And that is it for 10.7. So thank you, and we will talk to you later.